Professor Dr. N. Ganesh is working as a senior faculty, Department of Computer Science and Engineering, SRM University, City Campus, Vadapalani, Chennai. He has more than 12 years of undergraduate and postgraduate teaching experience, which includes 5 years of research experience. He has trained many corporate batches on technologies such as mainframes, Application Systems 400, SAP, ABAP. He has published 10 articles in both international and national journals. He has presented several papers in both national and international conferences. He has written 4 books which are prescribed in Anna University affiliated colleges, SRM University and Bharat University. His research interests are software engineering, data mining and cloud computing.
Welcome to UGC lecture series in computer science. We are going to see a series of lectures in the subject operating system. This is for the BSc undergraduate degree program pertaining to the students doing their 5th semester degree course, and this belongs to paper number 8. In today's session, we are going to see a topic on types of system. This is part of unit 1. So, as a contents, we will be seeing 1. Serial processing, 2. Mainframe systems, 3. Desktop systems, 4. Multiprocessor systems, 5th. Distributed systems, 6th. Clustered systems, 7. Real-time system, 8. Handheld system, and 9 is the ubiquitous computing. Now, what is a serial processing? I suppose you would have studied in your earlier days, in your schooling days itself, about the evolution of computer, how the computer was in the earlier days. So, in the serial processing, wherein all your data input will be processed in a serial way, in a sequential way, that is called as a serial processing, wherein you will be having all your data will be stored in the punched cards. You might be aware of what a punched card is, which is being used for storing the input values. So here in the punch cards it will be stored, and whatever you do, all your data, all your entries has to be done only manual. That is, there will not be any sort of interaction between the user and the computer in those days. So supposing if I want to enter certain input value, what I will do is I need to go into the room first of all, and then there will be a register. A register is a small notebook where I need to make an entry stating that I am going to do this kind of programming, a program on COBOL, a program on Fortran. Then I need to make an entry. I need to give the login time, that is when I am entering, and the logout time. Then I need to type my values on the punch card, and I need to give it to a supervisor who will be sitting in front of the system, and all the mounting and unmounting works should be done only by myself. So there will not be anyone to help me out. So myself and the supervisor will be there, and he will be monitoring how I am doing. So that is the work, and I have to do it. So this is a serial processing. This has been carried out in very olden days, wherein we do not have a concept of operating system at all. So all these things have been punched in the punch cards, and it has been given as an input. So that is how it has been done. So there is no concept of operating system in those days. So this figure shows a serial computing. So here these are the punch cards, and these people are having the punch card. So this will be a supervisor and the other person. So whatever data I am going to have, it will be stored over here and it will be given. And this is the register wherein I need to mark all the entries in the register, whatever I am going to program, whatever I am going to code about, and I need to give it to this particular person. So he in turn will insert in this area wherein it will be punched, and this is how a serial processing works out. So let me read out the topics that has been there in the serial processing. One is it has to be instructions has to be performed sequentially, and it has to undergo a FIFO basis. What is a FIFO? FIFO is a first in and first out basis. So whatever you give at the first, that will get executed first, and then you will get the output first. So if you are in a queue, if you are at the last, then your output will get executed only at the last. So if you are at the first, your output will get executed at the first. Then here in this punched cards are used. So jobs are firstly prepared and stored on the card. User does not interact with the system. So here mounting and unmounting has been taking place using a manual setup, and manual entry has been done in the registers. This is about the serial computing. Next is an operating system. Next is a system called as a mainframe system. A mainframe system was one which is being used in those days, even it is prevalent in the recent days. So in the mainframe system, a mainframe system, it is a server of servers. What does it mean? It is very big. It can occupy n number of volumes of data in it, and it can even work for 24/7. Nowadays mainframe system can work for 24/7, and it is mainly used in the ATM, the banking sectors, and then the financial sectors nowadays. And even to be frank, the Walmart company uses this kind of mainframe systems. So here it mainly uses the batch system. How it gets operated in those days? It uses a batch system. What do you mean by a batch system? A batch system is one wherein you given the input, that is, there will be a supervisor sitting in front of a mainframe system, and you are supposed to type in something in the punched cards, and you need to give it to the supervisor. The supervisor in turn, you will be coding it in a language called COBOL, let us consider, and the second person comes in, and if he is going to code in a language called Fortran, third person comes in if he is going to code in a language called COBOL, fourth person codes in a language called Pascal, fifth person codes in a language called Fortran. So there are 5 people, out of which first and third person has coded in program in COBOL, second and fifth has coded in Fortran, wherein the fourth person has coded in a language called Pascal. So all these similar languages will be grouped together, and it will be sent as a batch. So you will not be getting the output immediately, wherein you will be giving all the data to the supervisor. The supervisor in turn will collect it, and he will keep it on the table, wherein he will be collecting all kind of similar set of programs, and then he will be executing the similar set of programs. And the working style is, the program has to be submitted to the supervisor. Operating system will be using the load and run operation. That is, he will be first loading the job from the punched card and executing the instruction by using a run command. So it uses a batch system. So this is how a mainframe system works out. Even in today's environment, this mainframe system is working in such a way. It has been used even in the banking sectors. Say for example, if you have gone to certain banks during the working hours, you will be taking certain outputs of the passbook printout, or you may deposit or you may withdraw certain money from the bank, wherein after the banking hours, if you happen to have a chance of going into a bank after the banking hours, you can find the particular person, that is, there will be the printers will be rolling out. What do they do with the printer? Why does it roll out after the banking hours? It is because in the printer it will be taking the daily transaction report. So what has been happened on this particular day? That is an example for a batch system. The other batch system example you can say it as, say for example, you are getting your university examination results, and hopefully your university examination results you will be receiving only by midnight 12 p.m. So you mean to say that the controller of the examination and the university authorities, whomsoever it is concerned, will be sitting in front of the system by midnight 12 o'clock and they will be releasing their results? Definitely not. So they will be scheduling in such a way that this particular program has to get executed at this particular instance of time. So that kind of operation is called as a batch system. So it is highly common even in today's world. So this is how a mainframe system looks in. So this is a mainframe system that has been given by an IBM. So IBM is not the only vendor to use this mainframe. We have other vendors like HP, CDC, Honeywell, so on and so forth. But IBM mainframe is said to be pretty common. Hence, mostly we tend to take IBM as an example company for handling the mainframe system. But other than IBM, we have other companies even. So this figure shows a recent mainframe system of the Z10 architecture. Z10 is nothing but it is the name of the operating system. The operating system name is Z10. Z denotes zero downtime system. So 10 is the version 10. So here it will be operating without any downfall at all. So without any restart at all. So like in order to switch on or switch off a mainframe system, it usually takes 3 working days to switch on and switch off a mainframe system. So that is the reason people don't switch on and switch it off. This is one other mainframe system example. So the next is about a multi-program system. What do you mean by a multi-program system? From the name you can infer it as multi-programmers. 2 or more number of programs can be processed on a single processor, single uniprocessor. You will be having only one processor wherein you are going to code 2 or more number of programs. The processor may get overloaded, but how the program runs in. So that is called as a multiprocessor system. It is even common in many of the, it has been used in the research fields, in the areas like in colleges, in universities and in government organizations, wherein with one processor you give an input of different program inputs and you try to get the output, wherein your output may get delayed because that uniprocessor gets overloaded of too many programs. But even then all your programs will be standing in a queue and you will definitely get an output. So it can execute multiple programs on the system at a time, will provide the memory space to all the running and all the waiting processors. Input and output devices are very slow when compared to the speed of the processor, because in a multiprocessor system the input and output devices, what are the output devices? Say for example the printer. The printer gives an output very slow when compared to the speed of the processor, because usually the processor speed will be measured in terms of MIPS. What is MIPS? MIPS is million instructions per second. So millions of instructions per second a processor can execute. So when you compare the output of a printer or the printer speed with respect to the processor speed is definitely faster when compared to the input and output devices. This is an example for a multi-programmed processor, multi-programmed system and multi-programmed processor system. So here the speed of processor will be in MIPS. It allows more than one program to get executed at a single instance of time in a uniprocessor. Uni is a single processor. It is used in research, army, education and in government organizations. Next is about a time sharing system. A time sharing system, what do you mean by a time sharing system? A time sharing system uses, here 2 or more number of inputs have been given, but each program will be allocated a specific time. So for example, what happens is that so this particular program will be given for execution only 10 seconds. So this particular program will be given execution time of only 20 seconds. So within the 20 seconds this has to get executed. If it is not getting executed, then the other program will be staying in the queue. So this is called as a time sharing system, wherein it uses a concept called multitasking. What do you mean by multitasking? 2 or more number of tasks that has been performed at a single instance of time is called as multitasking. What is a multi-programming? 2 or more number of programs that has been executed on a single instance of on a single processor. This is multi-programming. Multitasking is 2 or more number of processes that has been, or the task that has been performed at a single instance of time is called as multitasking. So this time sharing option, it supports the concept of multitasking. So next system is the desktop system. Desktop system is one which we see on a day-to-day basis, which we have it in your regular homes, which we see on a day-to-day basis. So here in this desktop system, it has a concept of disk operating system. So we will see more about this desktop system after the break. Welcome back after the break. We were discussing about desktop systems. Desktop systems that we use, it is a system that we use on a regular daily basis, that we use in our homes. It is nothing but it's the personal computers which we use on a day-to-day basis. You would have seen everywhere, anywhere and everywhere. And with the commencement of the desktop system, this disk operating system came into existence. Disk operating system, which is nothing but the DOS, disk operating system, came into existence. So what is the advantage of having a desktop system? Here in your desktop system, the hardware cost is very less when compared to the previous mainframe system or when compared to the previous versions. This hardware cost is very less, and even the processing speed is much higher, and you have a user friendly environment, wherein here you can do an easy computation in the personal computers. It is used in homes. And the next system is the multiprocessor system. So what is a multiprocessor system? Here in multiprocessor system denotes two or more amount of processors are simultaneously working is called at a single instance of time. You call it as a multiprocessor system. In the before few minutes we are speaking about multitasking and multi-programming. Multitasking is two or more number of tasks that has been carried out at a single instance of time. You call it as multitasking. And multi-programming is two or more number of programs that gets executed at a single instance of time. You call it as multi-programming. Now multiprocessing. Multiprocessing is two or more number of processors gets into work at a single instance of time. You call it as multiprocessing. In a multiprocessing system, what are the factors that are available? Here it is also called as a parallel system, or it is called as a tightly coupled system. Why do people call it as a tightly coupled system? It is because as a tightly coupled system wherein it shares memory. So when you share memory, you call it as a tightly coupled system, and it has a concept of symmetric multiprocessing. It uses Flint's taxonomy. What is a Flint's taxonomy? Flint's taxonomy is one which has all these four factors. One is SISD, MISD, MIMD, SIMD. SISD denotes single instruction, single data set. MISD denotes multiple instruction, single data set. MIMD denotes multiple instruction, multiple data set. SIMD denotes single instruction, multiple data set. The single instruction, single data set, it uses only single processor for its execution, and this multiple instruction, multiple data set, it uses parallel processing, or multiple processors are being used for carrying out multiple set of instructions. Single instruction, multiple data set also uses parallel processing because it has multiple data sets, wherein this MISD, multiple instruction and single data set, it is not in use till date. It is being used only in the research areas. Then what are the advantages? Now let us see the advantages of a microprocessor system. There are three different advantages in the microprocessor system. Number one, it has increased throughput. Number two, economy of scale, that is, it is scalability. Number three, it has increased readability. So these are the three advantages in a microprocessor system. Then let us move on to the next system called the distributed system. In a distributed system, what is a distributed system? You would have heard of a distributed system in your daily life. That is, say for example, if you are going to have if you are going for a internet shop and if you want to browse certain sites, if you are going to type in the URL as google.com or as yahoo.com, you mean to say that, or how do you get the output when you type in google.com and when you type in certain search values, something like some meaning, if you want to find some meaning in the search, if you type in, you get the output within fraction of seconds, something like 0.03 seconds, 0.05 seconds. So do you mean to say that how is it possible for the Google to fetch output at a very faster rate? If you say that you have only, it has been retrieved from the server, do you mean to say that you have only one server? No, all your data, it's been distributed. You will not be having only one server, you will be having many proxy servers, something like Yahoo, or say for example the Yahoo Mail or the Gmail, wherein you will be having all the proxy servers across the globe, and all your data will get stored at one server location. So supposing if you are going to give an input and if you are going to wait for the result, it will be hitting the first server that is located in, say for example, you have one server located in Bangalore, the other server located in Noida, the third server located in California, fourth server located in Australia. So it immediately it hits, when you type in a keyword and give a search key, it immediately hits the Bangalore server. Supposing the Bangalore server is busy, it goes to the Noida server. Supposing if that is busy, it goes to the US server. Likewise. So it goes to the server and it fetches the value at the earliest. So this is a concept of distributed computing. All your values are being shared or are being distributed across the globe, so that the retrieval becomes faster and efficiency increases. So this is how in the distributed system it is loosely coupled system. Loosely coupled as each and every system, it has its own memory. For you, according to us, when we type in the keyword and when we press an enter, for us we think that we get the output from a single system. That is our thinking. But actually what it happens, it fetches the output from a different set of proxy servers, from a different set of servers which has been located across the globe. So what happens here is each and every server has its own memory. It is not been shared, it is not a common memory. One server has one memory. So example is the Yahoo and the Google server. And then the other distributed systems are, one is the client server system, the other one is the peer-to-peer system. What is a client server system? A client server system is one wherein you have one server, and that server is being connected with 5 or 6 different clients, or in other words 10 clients gets connected to a single server. It does not mean that you need to have only one server, you can even have a proxy server. The other thing is the peer-to-peer system. The second type of system under a distributed system is a peer-to-peer system. What is a peer-to-peer system? Peer-to-peer, from the name implies, peer-to-peer is a point-to-point contact, a direct communication between the server and the client is called as a peer-to-peer system. So this is also a type of a distributed system. Then the next, so now let us see a diagrammatic view of a distributed system. So this is how a distributed system looks like. So here from this area, one person types in a value for a Google, for a Gmail. Here from this locality, this person types in a value for a Gmail. So here and all you will be having the proxy servers in these locations. So when it goes here, when this server is busy, it immediately goes here. When this server is busy, it immediately goes here. And finally it retrieves the data. So it is a more efficient system. Distributed system is one of the efficient system. Then we go on to a next system called as a clustered system. What do you mean by a clustered system? What is a cluster? Cluster is forming groups. So like you have a big task. Say for example, you have a very big task that is to be completed within a short amount of time. So when you have a big task, so that task gets subdivided into smaller programs, and if it is been given to n number of people, and finally all your output, all those output will get integrated and you get a single output. That is called as a clustered system. A clustered system is one wherein you have all sort of groups, so all sort of similar groups. So here you have a task of doing a very big project, and say for example you have a team of 10 members, and what do? Will you be allocating the entire project task to a single person? Definitely not. You will be splitting it into equal modules and then you will be assigning it to all the 10 people whoever has joined that particular team, whoever is part of that particular team, and then you will be getting the values from them. But all these people belong to a single team, that is, they belong to a single cluster. So, such a kind of system you call it as a clustered system. So, this is one other system. Then the next type of system is the real time system. What do you mean by a real time system? Where do you use a real time system? A real time system is one wherein you give the input and immediately you get a response. Say for example, you are traveling in a flight and if there is a problem in the flight, the pilot, what he needs to do? He needs to immediately report to the control room. So, when he is going to report to the control room about the problem that is prevalent in the flight, then he should immediately get a response from the control room, either he needs to land or what other options has to be followed out. So, that is what the personnel from the control room has to do it. Supposing if there is a delay in that, then the flight may result in a crash. So, this is an example for a real time system. When he is going to shoot out an input, he needs to get an immediate response, that is called as a real time system. And online transaction processing is a real time system. You go to an ATM, you withdraw certain money. What do? You just insert your card, you type in your password and you will be prompted with a menu what needs to be done. So, you press a withdrawal key and you get a withdrawal screen wherein you type in 10,000. So, what it does internally, if you have a valid input, if you have sufficient amount of money, it goes inside and then it will be checking for the amount details and then 10,000 rupees you will be getting it. So, you give an input and you get the output. So, such a kind of activity is called as a real time system, and this real time system is broadly classified into two types. One is called as a hard real time system, other one is a soft real time system. A hard real time system is one wherein the CPU will be processing the data and as we enter the data, wherein there will not be any sort of seconds left out. In the case of soft real time system, the CPU performs the operation after a microsecond. So, supposing we want to change something within that microsecond, you will be allowed to change something, that is called as a soft real time system. Then the next type of system is the handheld system. In a handheld system, what do you mean by a handheld system? The mobile phones, the devices, the laptops, the iPads, everything is said to be a handheld system. Okay, what is the advantage of having a handheld system? It is easily carryable, it is easily portable. So, wherever you go, you can have your mobile access, you can have your internet access. So, such a kind of system you call it as an handheld system. And then the next system is nothing but the ubiquitous system. Ubiquitous system is otherwise called as a pervasive system. Pervasive system is also a type of handheld device wherein you will be communicated with the network. Wherever you take your handheld device, it will be communicated to the network, or you will be having an internet connectivity. Wherever you go, your network follows. So, that is the ubiquitous system. So, now let us see a diagrammatic view of a ubiquitous system. So, here in the mobile device, you have, wherever you go, here you have a network adaptive transfer protocol to transfer your network views, and this is how the ubiquitous system works in. Here it works in a mobile phone. Now, let us summarize the details that we have seen in today's lecture. We have seen the different types of system such as mainframe system, desktop system, distributed system, multi-programming system, ubiquitous system, handheld system, and we have also seen the working style of all these systems. Now, what are the possible questions that can arise from this particular topic? Question number 1. How was the user's identity maintained in the serial processing? I said it can be maintained using registers. What is a batch system? What are the advantages of a desktop system? What is a multiprocessor system? What are distributed systems? mention some of the handheld devices. What are the handheld devices? You know, you might be mentioning it. Something like the mobile phones, iPads, so on and so forth. Ubiquitous system computing is otherwise called as pervasive computing or pervasive system. So, with this, we come to an end of this particular session. In the forthcoming session, we will see more topics on the subject operating systems. Thank you.